Mr. A, are you confused about simplifying square roots? Then you're in the right place. Let's get started. If you look over here at this chart, you notice you have what we refer to as the perfect squares. What do we mean by that? If you take any of these numbers on the left side and you multiply them by themselves, you get the number on the right side. That's why it's called a perfect square. We want to look at how do we go backwards from that. If we have, for example, 25, how do we know how to get back to the 5? In order to do that, we look at something called the radical symbol, which for today will allow us to take a square root. If we take the square root of 25, as we already talked about, we know that will go back to 5. This would be what we refer to as the exact answer. But what happens if you don't have one of these perfect squares? What if you have a number like 50? How would you get an exact answer? And no decimals, please, no calculators. How would you get this answer to be an exact answer? Well, you want to see what perfect squares you have that are factors of 50. So for this example, we know that 25 will multiply to 50. So we can take 50 and break that down into the square root of 25 times the square root of 2, because 25 times 2 is 50. And what happens is the square root of 25 we know is 5. So that will simplify to a regular number 5. The square root of 2 we unfortunately can't do anything with. So this is what we refer to as an exact answer. Let's take a look at another example. What if we look at the square root of 72? So the square root of 72 we can break down into 4 times 18. So this would become the square root of 4 times the square root of 18. Once again, because I know I can break down the 4. Square root of 4 is going to simplify to 2. But the issue with this is I have to then break the 18 down again because I know 9 times 2 is 18. So this 2 has to stay where it is. And then I'm going to repeat this process over for the 18. I'm going to break this down into 9 times 2. The square root of 9 times the square root of 2. I know the square root of 9 is 3. So now I have 2 times 3 in the front. And the square root of 2 will remain. 2 times 3 is 6. So I end up with 6 square roots of 2. Let's look at 72 one more time. The square root of 72 can also be broken down into 9 times 8. So we would do the square root of 9 times the square root of 8. We know the square root of 9 is going to be 3. Again, referencing our perfect power sheet. And the square root of 8 will once again have to be broken down. The square root of 8 would become 4 times 2. So we have the square root of 4 times the square root of 2. The square root of 4 becomes 2. So now we have 3 times 2 times the square root of 2. 3 times 2 is going to give us 6. So notice that we arrive at the same solution, but we did it 2 different ways. Now, if you're pretty clever with this and you're pretty quick with this, you'll realize if we look at the square root of 72 one more time, I know that 36 times 2 is going to give us 72. So we can do the square root of 36 times the square root of 2. The square root of 36 becomes a regular number 6. The square root of 2 remains under the radical. Notice we got the exact same answer 3 times. My personal preference is the square root of 72 being broken out into 36 times 2 because it's going to be so much faster. Okay, folks, before we go, let's take a look. If you'd like to practice one more on your own, please go ahead and try the square root of 44. Pause the video, and when you think you have the solution, you can come and check it. Okay, folks, so you should have gotten the square root 2 times the square root of 11 as a solution for that problem. If you'd like to try one more practice problem, why don't you go ahead and try to simplify the square root of 180. Press pause. Okay, thanks for rejoining. The square root of 180, there are multiple ways of doing it. This will simplify to 6 square roots of 5. So if you were confused about simplifying radicals, I hope you find yourself in the right place.